So good afternoon to one and all present here. So we are moving on to the session 3 of day 3. So today we have the eminent professor from Sri Ramakrishna Engineering College, head of the department robotics and automation. So Dr. A. Murugaraj, as I have already mentioned in my inaugural speech, he is the mentor of this particular Sttp. So happy to invite Dr. Murugaraj for this particular section. So he is going to talk about the smart sensors for digital manufacturing. So let me invite Mr. Nibin for introducing the speaker.
Good afternoon all. Today, the third session will be handled by Dr. A. Murugarajan. He is currently working as a professor in the Department of Mechanical Engineering at Sri Ramakrishna Engineering College, Coimbatore. He has completed his PhD in Mechanical Engineering from IIT Madras. He is a university gold medalist during his Masters in Industrial Engineering. He has completed his MBA in Operations Management in IGNOU, New Delhi. He has 18 years of academic experience, 5 years of research experience, and has published 24 research papers in different journals and conferences. He is associated with industrial consultancy projects by SREC Innovation Center and is a technical member and reviewer of 2 international journals. His major research areas includes mechanical measurements and metrology, optimization techniques in engineering and operations management, predictive data analytics, machine tool metrology using sensors, and natural fiber composite manufacturing. So with immense pleasure, I welcome Mr. Murugarajan to handle the session. Welcome, sir.
Thank you, Niveen. Shall I share my contents?
Yeah, sure.
If my PPT is visible, have any problem for our participants?
It's clear.
My PPT is very okay. Okay, first of all, I'm welcome you all for this AICT sponsored STP program on IoT-based manufacturing and design and the challenges and the opportunities by Vishwajyoti Engineering College. First of all, I have to thank Professor Shanmugesh for giving me the opportunity to talk on this particular STP program. As introduced by Mr. Vipin, I think I have professor from mechanical previously. Now I have before I think this year started, I have shifted into the robotics and automation, heading the robotics automation. You know that currently, so the industry revolution mostly depend on automation. So we have introduced this particular B robotics and automation. So that's what. Okay. So thank you. So we can start. My presentation contains around of 60 to 70 slides. Don't worry. Possibly I don't want bore. So maybe mostly we can make more interaction if possible. And also end of the session, we should have some kind of questionnaire sessions by online form. I have some of the questions to you, and also some videos also is there. I try to cover the portions what I have in my mind regarding the smart sensors for industry 4.0 digital manufacturing. So so we can start my presentation. Hopefully some kind of insights you can take away from this particular topic, because you know that currently everyone is talking about the industry 4.0 cyber physical system, data analytics, big data. So whether they are coming from the background of mechanical or electrical or electronic or maybe a civil, whatever you have come from the background, the word which is a catchy word now they have been talking in all kind of industries, AI, like that artificial intelligence, data analytics. This is a word I'm lost almost 1.5 years when I have been interacting with consultancy work for industries, because I have involved some of the 4 to 5 consultancy work from Transform Automation, L&T Technologies, the L&T valves, then bimetal bearing, and also with Robert Bosch. Some of the projects what we have handled, I am one of the facilitator for when you're handling some of the project works, but mostly and also Wipro automation, but we have been trying with Wipro automation. But when we have been discussing with most of the people, they're always talking about the industry 4.0. So how far the smart way of to connecting the devices and equipments which they have already have in their industry. So that's what is one of the interesting topic, because IoT based manufacturing and design, it is going to rule the next decade, because so far what we are talking about the traditional manufacturing, you know that when we want to talk about the more on industry 4.0, but generally, yeah, any chat information, I think if I'm missing something, please Vipin, somebody is there, I think you help me. I couldn't see here chatting. If there are any questions also, please you can interact with me. You can put it in the chat box, so I will try to answer your questions. Okay. So when so come to the point, industry 4.0. So mostly they're talking about the smart connectivity point of view. When they are asking about any project to our students, they are always talking about this particular perspective, whether how we have to connecting the machines and equipments, how we have to convert. You know or not that because we have to accept, because only 9% of the industry in globally they have digitized. So this is data from the Price Cooper Analytics Corporation. They released to 2018. So there are 91 percentage of the industry they have been partially implemented, or maybe or 20%, 40%. So there is a big scope for the in the industry revolution. So there is a the possibility of connecting or maybe fully digitized manufacturing to be happening in the coming days. So there is a big scope for this particular field, like Internet of Things or something. Okay, I think a morning, I think one of my professor, Dr. Samuel, I'm a student of Samuel. So he maybe he have interacted with more on the all smart factory and smart manufacturing, because all are mostly the similar term. They have catchy term they have using in different uh, situations they are using here. So there, we was talking about all 3D printing, robotics, additional additive manufacturing, the advanced simulation, virtual reality, augmented reality. You can big data. You can say then you can say about all taken cyber physical system. They all have been talking about this all digital twin. These all technologies now they have been talking. They have been talking about the in the research and also the prototype aspect. But there is a big scope is there when we have been talking about the foundation for this all talking about this all technologies. The foundation will come from the smart sensors. That's what I'm going to talk in tomorrow today's class, today's seminar. So my contents of my presentation very crispy. I think maybe I have some of the other slides also there, but I'm talking about mostly focus on these smart sensors and what is the role of smart sensors in industry 4.0 and digital manufacturing. That's what I'm going to talk about today's seminar. Just I'm trying to fulfill. So my outcomes are, at least if I answer some of the questions, if you are put some of the questions to you, so at least over 60 to 70% of the participants, they can able to understand. So what sense I'm talking about these smart sensors in in industry 4.0. So come to the first slide. I think it's a very interesting factor. I think if you could see here, so last 4 to 5 decades we have been talking about this all, but it starts from 18th century, 1900s. They're talking about the mechanization through power and steams. The first industrial revolution happened during that particular time. After that, slowly they're using water and the steams they are used for to make some kind of mechanization, do the some kind of operation. But slowly in 1950s and 60s, they have started the invention of this electrical things. So the mass productions are happening through the electrical motorized things are come in the picture. In late 1970s and 80s, they have been starting about the invention of good electronics and integrated circuits, and computers come in the picture. So they have control through this all, through the automated through this all computers and electronic devices. So there they are talking about the instead of the human being. So they have deploying the robots for the third industrial revolution. Now we are enter into the fourth revolution, fourth industrial revolution. That's what industry 4.0. They have been talking about the fourth industrial revolution, but this particular word industry 4.0 is mostly is captured from German, because Germany, they want to make a fully automation, so they have been talking about in 2000, maybe near to 2000, they want to take a second innovation technology, want to go what is second industry revolution. So they coined this particular term industry 4.0 from 2000. After that, all of them are use that particular word industry 4.0. Then they have been talking about the automation through how we are connecting the all equipment devices through your communication media. So communication through communication protocols and other things. So how we are going to integrate with all the machines through artificial intelligence and internet of things, because initially only the sensors or whatever the equipment, it will going to only sense it, and it will give you it won't think. But after later stages, they have been talking about this all the uh, uh, usage of this all artificial intelligence and IoT. So fourth industry revolution, we have been talking about the industry 4.0. There's a connecting and getting the responding and feedback and everything, so we can do the our industrial operations. So that's what when talking about the industry 4.0, so it improve the productivity in the entire manufacturing industry, because ultimately when you're talking about the entire manufacturing, not only a single equipment or single machines, because is a the combination of n number of machines, combination of n number of process which is involved in the industrial. So there, how you are going to connecting this all, so in the factory or through your various product life cycle system. So finally together, how we are going to managing those informations through for the better productivity and good quality. That's what they have been talking here. The same, the vice versa, they have used the word of digital manufacturing, because digital manufacturing, so there is a in line with the industry 4.0, because they're only talking about in terms of manufacturing aspect, especially in machining and other aspect, but generally they called integrated approach using the computer for to combining the starts from raw material or supply of raw material from processes and other services. So that's what they're talking about the digital manufacturing. So when they're talking about the industry 4.0, then finally the word which will come with from the picture, so we are using IoT, but IoT, how we are going to connecting with industry? That's what they are using the word IoT. Both are they're using for the revolution aspect, but generally when talking about the control, when talking about the automation, so IoT will come in that picture. So all are maybe a very similar terms, but there are very catchy terms they have been using. That's what you should always to understand in this particular perspective, because when we are become more smarter, when you are using your digital technologies, how the data to be generated, how the data to be communicated, how the data to be processed, which will be useful for your enhancing your production process, and by the way at which you are going to improve your product quality and flexibility and increasing your productivity. So but whenever you have been talking about these all processes, the finally without sensor, that's what the sensor, the first of the primary element, is one of the primary element in any kind of a industry. If you're talking about industry 4.0, if you're talking about the automation, if you want to go talking about the controls, if you want to talking about the communication, if you want talking about I want to do some getting a feedback something, so ultimately the sensors will give the sense the information, directing the information, acquiring the information, grasping the information. You can take anything, you can monitoring the information. But once if the data to be generated, how you are furtherly using this particular data for the different aspect, whether it's maybe for the self-control or self-diagnosis or self-monitoring or self-configuration, whatever may. So any kind of a process without smart sensors, the word I'll come back to you smart, but without the sensors, not at all possible. That's what the sensors is going to rule the world. So you know that if currently you are using so many devices, like your starts from your mobile phone, you are always using your packet, you are using a lot of wearable devices like smart watches. It will show you every second, show about your heart rate or maybe BP level. So it will going to give you a lot of informations. It will give you the generating the data every second. So once the data are generated, but the next stage is very important. But the data, when you're going to use the sensors, how you are the quality of the data, because any data, any unwanted data, it won't give you any, but your quality of data is one of the most important for any kind of a sensor. How it give you the sensing the or grasping the information which is using element, how it is converting those information starts from the thermocouple or so many devices are there, but sensor is using element, how it is converting those information starts from thermocouple or so many devices are there. So so how it is detecting some of small the mercury, it will going to change its physical properties when you are doing some kind of heating. So how it is converting, how we are converting, so in transmitting, and finally going to display in the respective unit. So the first, the foremost information sensor. So without sensors is not possible. We can going to talk about the industry 4.0. A small video. Could you please check with industry 4.0 by Volkswagen group? They have been talking about this. So I think my video is visible only. If I have any problem, please let me know. Okay, so if you see this particular video, so Volkswagen they're talking about what's the production today, and so what we have been in the industry 4.0. Because when we are talking about the usage of all the advanced equipment, starts from the advanced robotics, then they're talking about the simulation, the virtual reality, so many things are there. But thing is, when they're talking about this all, the basically the sensors is play the major role when they each and every time to sense it, and we can do the operation. So there the sensor come in the picture. That's what I've been talking about here. When they're talking about the industry 4.0, it starts from the design of the image, and finally come to the final stages of your the production. So how the all the image data to be converted into the real-time product is maybe a prototype or maybe a real-time fabrication model, but each and every stage how the transmission of those informations through a sensing of through the sensors at which it will going to make it a final production. That's what. So digital manufacturing enabling this all, so it will give you the integrated approach to manufacturing, so through your the computer system. So ultimately the primary sensing elements will detecting those informations, like if you have the image you are capturing starts from your camera. So how the camera is one of the sensing device, so it will going to capture the information, you're going to transfer the files to the respective manufacturing department. So the respective manufacturing department will generate automatically, will generate there the come in the picture, the software automation will come. So it will going to identify what are the sequences of operations we have to perform in the particular machine. So like that it will start. So if you are executing the machine tool, any CNC or any kind of a machine tool or robotics, so any robo, so it will going to pick the part. So whether if you're going to pick the part, it always going to check with what kind of drawing they sent by the client or customer, then it will check it, then and it goes to the place it in the respective machine tools. Like that the process will start from the digital manufacturing, they slowly put it in the system. So that's what they're talking about the industry 4.0 and digital manufacturing. And thanks to my professor, I think somewhat he has covered all the topics related with this all system. When we are talking about the industry 4.0, how we are going to materializing the industry 4.0. So we slowly start from the product life cycle. I told how the product is designed and starts from the life cycle of the entire life cycle of the process, from raw material to the end of the client and maintenance, and so after the post uh, services, post usages also, post service usages also. So they have been talking about the mostly on product life cycle, starts from raw material to the end of the product. So the second thing is very important thing is what I have to convey here is a smart factory or digital factory or smart industry or smart manufacturing, the word. So it mainly plays with smart machines. We can say smart machines means we can intelligent sensors we are placing here. There, how the intelligent sensor connecting with all other devices in the smart factory or smart industry. So that's what they're talking here. So it involves use of smart machines and sensors and other tooling devices to provide the real-time feedback. This is very, very important one. It give you the real-time feedback and executing the tasks in the manufacturing. So this is what is very, very important one. So this is a digital transformation. This is a digital transformation through all your sensors and the internet of communication devices at which you are enabling the digital factory or smart factory. Then finally, the value chain management for the optimal of your processes, like your sales and service and marketing, other things will come in the picture in the streamline of your manufacturing your system. But apart from this, how we are going to enabling this all technology will come in the here, because when you're generating using the sensors, you are going to generate a lot of data, because so many data are floating in your system. How your storage of those system, then how you're going to add the intelligence, that's what artificial intelligence are come in the picture here. So how these innovative technologies will help you to materializing the industry 4.0. This is one of the major one when we are talking about the materializing the industry 4.0. Then apart from this, the smart factory will come in the picture. So we slowly put it in the smart factory. So without smart factory, industry 4.0 is not possible. But there you have to make a lot of equipments. The equipments have all kind of control over your usage of robots and sensors, and connected to your network to visualize the various kind of information. That's what this is one of the major one what I want to convey here, because if you have more number of factories or the factory have a number of equipments, how we are connecting the factory through your customer. That's what the word is very, very important one. If you could see here when so if you could see here, sorry, I think my ball pen is not working, I think so, highlighter. If you could see here, the customers are the most important one. How? Because as if everything is now, once upon a time the manufacturing sectors are manufacturing driven, because you can see that once upon a time the ambassador cars only the car which is available in the industry. There we don't have any option. If you want to go for the car, we have to go with ambassador. So whatever the color is available, you have to buy it. But now it is totally different, because I need the car at which this particular facility you have given lot of conditions, and also what of the available features, what are the features you want. So based on this, so once if you are given a customer features, then automatically goes to the manufacturing end. So they will start to manufacturing, adding this all. Some of the basic skeletons are available, but furtherly they have added with all. So that's what here the smart factory will come in the picture with how is orientation with the customer feedback and customer aspect of expected quality. So that's what is very one of the important ones. So now, sorry, okay, yeah, sorry, some mat is missing. Okay, okay, okay. So is one more video about the smart factory. So what is the purpose of smart factory? Everything they will say you. So if you could see here, when the Simons are talking about this all design to cost, design to logistic, design to make a quality product within this specific period of time. So they have to make a simulation. The once they have make a digital prototype. So then furtherly they have to simulate the environment. Then furtherly they go for the real-time manufacturing to ensuring the good quality of product. So there they are making of the usage of the smart sensors will come in the picture, they when they have been talking about the Siemens industry software. So they have ready-made smart sensors which have integrated with their systems, at which they ensuring their the production capability where they want, wherever they want to make a new kind of a layout system, smart industry systems. Now coming to the smart sensors, where the smart sensor play the any kind of industry 4.0. If you could see a pyramid structure, so they're talking about the that's what the Siemens software system will come in the picture here. Manufacture execution system, MES, SCADA, ERP. They have been talking about this all perspective, but when I come into the basic level, then when the sensors and actuators are the most important devices which have been used in the any kind of industry. So this is the bottom of the table. So it will only give you the quality of the data, the data to be communicated, and it control the entire process to be automated. Then finally they're talking about the digitization and digital factory. So the sensors and actually the bottom of the base of any industry 4.0 when I have been talking about the industry 4.0. Now, when talking about the sensors in industry 4.0, there are a lot of sensors they are using, but the word which will come in the picture here, sensors 4.0, because there also they're talking about how the industry 4.0 they have been talking, and we have been talking about the sensor 4.0, because generally the sensor they are the organs of any machines. If you are going to develop any machine, if you want to develop any machine, you want need some kind of control, you want to give some kind of feedback from the machine. So some kind of the data, how the displacement is happening, how much distance is moved. So everything is dependent upon the what kind of sensors you have placed in the particular machine. So that's what the sensory organs what we have in our human being, the same thing also the machines. So it is essential for one of the factories. Suppose if you want to go for the digital factory, so without sensors not at all possible. So generally the sensors what they mostly they're doing with acquisition, collecting, detecting. So it will going to give you the basic processing. Then finally how the IoT we are connecting those all data, and from the data you have to make a decision, some kind of decision making. So that's what they have been talking about the sensors point of view. Then finally now they have been talking about how the embedded systems and the microprocessors are integrated with the sensor, and finally you are going to make a coding into adding some kind of intelligence based on the data point, data values, how we are going to take the decision to actuate the actuators at which we are to perform the any kind of job in the machine or maybe the robot when you're doing the better production or optimized production. So that's what, so the sensor 4.0, when we are talking about industry 4.0, then we have been talking about the sensor 4.0. That's what generally sensor they're talking about only the sense, but here we have to talking about the starting to think. So what we have to take the decision, sometimes a self decision or self controlling or self diagnosis or self calibration. So these are the functions it can be carried by these sensors. That's such a way they have to define design by the sensor, because once upon a time the sensors only give you the transmitting, the transforming the information. Then finally we have a lot of electronics at which we have analogically we have to get the value, or manually we have to represent it, but not nowadays is not like that. So we have sensing electronics inbuilt in the sensor at which it will generate the data, and we have small memory space and processing unit at which it will going to take the decision. That's what one of the major digital transformation happening in industry 4.0 when using about the smart sensors. So that's what the prognostics they have been talking about these all informations, and cloud-based IoT and other digital twin. Digital twin is a base for one of the base sensors is the base for when you are talking about the simulating the virtual real-time virtual environment using the data collected by the sensors in the sensor machine in the smart machines. This is a study they have been talking about the 2 to 3 years back in 2020 somewhere, the Internet of Things connected to the internet, but still they have been talking here about the Internet of Things usage of sensors. we have not achieved this much of level, but still the long way to go for when fully implementation of IoT concepts in the machine tool industry or any kind of industry. Not only for machine tool, I have been talking about in line with the machine tool, but generally healthcare, any fleet management, any system. Slowly, if you see Ola, if you see Swiggy, they have been talking about the connecting the people. They are using with your data, then they have using their mobile phone at which you are connecting. Similarly, for when come to the machine tool, still they have been talking about this all. But the thing is, when talking about the sensor, about the smart sensors, the cost play the major role, because in 2 to 3 decades before, when I am doing my research work in IIT, when I am purchasing a high capacity, high resolution, high precise capacitive sensor with the cost of 4 to 5 lakhs, only the sensor, then the sensor electronics controller have a separate box. You have to purchase for another 4 to 5 lakhs in separate box. Then you have to purchase separate power connection. So many things are there. Yeah, separate entities. Then you have to buy. Then you have to make it, and you connect it through your LabVIEW something or some other virtual platform to ensure that these all things are. So now the cost has declined somewhat compared with the last 2 to 3 decades. So now a lot of ready-made sensors, like you have a USB port and other wireless connectivity, are come in the picture, because whether you are connecting through hardwired or maybe connecting through wireless, the Bluetooth technology, everything is now evolved with the low cost. So sure, there is another one decade we are fully connected with the sensors. So that's what I told already. The sensors is going to rule us after some point of time. So it will give you the directions about when you are wearing with any smart devices or smart sensors. Then if you are in the smart house or smart grid or smart the education systems, everything it will give you about the all data to you, and it will going to direct you what you want to do for after a particular time. After the next minute, I think it will going to communicate to you. You should have go for this. You have to go for this. So like that, it will going to give you. It won't give you free for you when you're going to go with the sensors. But anyway, we don't have any options, but we have to go with this particular technology. So when talking about the sensors, not the sensors, sensor 4.0 are talking about the smart sensor. So once upon a time, so in 18th century, they have been talking about the mechanical type of arrangement at this. So mechanically, it's going to floated. We can like a lot of pressure transducers or mechanical elements what we have using in our in olden days, all voltmeter, ammeter arrangement. We have some kind of analog devices. Then slowly the electrical technology will come in the picture. So we are going to use the passive type of sensors. We are generating the power. We are giving the electrical power that which exciting the signal. Then furtherly we have changes in the signal based on the environment. So it will going to convert in terms of electrical signals. Then slowly the sensor 3.0 come in the picture. Usage of computers and digital interfaces through electronic system integrated circuits. So they have embedded with the sensors with these all equipments. Finally, the smart sensors will come in the picture. Here we are adding, so the sensor 3.0, we have separate entities, but now the sensor in 4.0, we have processor, we have memory unit, we have communication capability. So we have this all together, they're making in the smart sensor for sensors 4.0. So today we cannot roll out with the old technology, but we have go with, because whenever we are having using a lot of digital technologies, it may be obsolete for some point of time. So ultimately, if you go with sensors, if one sensor fail, we can't go and correct it. If you are malfunction, you have to throw it and fix it. Easy assembly, and easily we have to detect it by the sensor. Because if you are if you are through connected through USB, so your the software platform is going to identify something is connecting to me. So like that, that's what the computer also is like a sensor. So one more sensor to be added, so it will going to identify or detect and grasp something is there. So based on this, it automatically going to upload those drivers from the internet. Then finally, it will give you have added in your system. You can go and do for your operation. So like simply a mouse, we can say that. So similarly, we go with connecting with our human. So how we have taking this all 5 organs like smelling, hearing, touching, tasting, vision. So it's always a very complicated mechanism what we have. But when we come into the convert into the electronic brain using a sensors, because we have using this all. Like if you see this particular film thing showing in 2014, hopefully, I don't know exactly 2014, as a long time back. So he's on superior brain. He is predicting something. He advancedly know about this all. So like that. So some kind of I go with the superior state. The similarly for the sensors what we have, where we have to go with the particular stage or we don't know, because some of them has some kind of capability. They can identify, they can predict. But how the smart sensors will come in the picture, because these sensors mostly we have taken from the what we have seen, what we have touched, what we have smelled, what we are hearing. Based on this only we have been using in our the industry commercial automation purposes. But finally, how it goes to the superior state, how intelligent enough to identify himself, itself. So that's why they're talking here. So you know that sensors are already everywhere, so we can't avoid, because whatever technology so far we are using in our day-to-day life, we cannot avoid. It starts from washing machine to so using the digital thermometer, and whatever we are using, car, camera, so anything in mobile phone. So everything will be digitized. Whether whatever the value existing, it will give some kind of quantity of information, but we have to ensure that what kind of quality of data it is given by the sensor. That's the biggest problem, biggest issue when you have been talking about the sensors point of view. That's one of the major one. When I always whenever I'm talking about the sensors, this is one of the major problem, because sensors data, whether it's you are getting a quality data, because it give it a lot of information, but how we are going to identify the information is really a realistic one or not. So that's one of the major one. The next thing is when talking about the sensor, you should know what kind of type of sensors and the role of, what is the role of sensors in any kind of industry. Suppose if you're talking about industry 4.0, but how the whole type of sensor are going to connect with this all. That's what we have listing. I'm listing the more. These are the sensors mostly used in all kind of industry. For if you go with any industry 4.0, any industry, any automation industry, maybe you can see any one of the sensor they have using continuously in their in the their industry, their industry, or maybe in their automation. So like starts from the vibration, acceleration measurement to the simple measure of pressure, temperature, and displacement. So these are the sensors. How these sensors will give you the smart phone or smart car or smart grid or smart home. You can see all. So without these sensors, we can't talk about this all factory automation or digitalization, industry 4.0, whatever you are talking about the smart city or smart nation. Without this, not at all possible. So these are the sensors. It going to translating the physical world into the digital world. So these sensors only converting the physical information. Suppose you are going to find out the level of your water, but you need some kind of a primary sensing element. It will sense the information, then it will give you converting into the digital, into digital information. So further the digital information to do the some kind of action, whether I have to go, otherwise I have to stop. So like that it will give you the decision. So the sensors data will give you take the decision making process. So that's what it will give you, sensing, feedback, whether we have to go with further or smelling, smell aspect, gas sensors or chemical sensors, emotion still they have been working with so many aspects in robo, but still so they have been talking commercially is not available, but they have been talking about the emotional type of sensor. Condition monitoring, we don't have any option, so we have to go with the particular one. And you know that predicting and responding, that's what the prognostics and diagnostics of sensors is major role in the coming days in digital twin. Coming back to the concept of smart manufacturing with respective perspective with smart sensors, and the problem is you want to know the real-time performance evaluation, because one of the major one, because when talking about the measurement perspective, because when I have been talking about the measurement and sensors, so whatever exists in some amount, there's a word I am always using, because by one of the famous personality, meteorology personality, talking about this. This last slide I will show you that one. So whatever exists, how the real-time existence value, how we are going to connecting with your sensors. whether it's correctly giving the information or we don't know. So that's one of the biggest problem when talking about the perspective with the smart fan, whether it give you the perfect data or not. Apart from this, other things like in-process measurement, then robust data collection and framework, some of what kind of framework if we are connecting with all sensors, what kind of uncertainty, because one of the major problem when talking about sensor measurement of uncertainty. So how many data you need to ensure that it's maybe a quality of data. So whether it's maybe a frame by seconds by second or millisecond, or the ways a particular minute getting the data. From there, what kind of statistical mathematical features you have to consider, your modeling your data at which you are going to say about your what's the quality of the value. Then I told already the prognostics, a healthcare monitoring system, because when you are using your all your machine tools or whatever machine you are using from the mixie to the washing machine to whatever the industry CNC machines in the industry. So ultimately, health caring of that particular machines are very very. So how you're going to identify? I'm going to my bolt nutters are having a problem or my bearing is having suffering. So lot of the components it will going to say about I'm going to fail, I'm going to fault, I'm going to after some point of time I'm going to fault. So could you please change my component like that? It will going to say some point of time, but how we are going to identify based on the connectivity between these the smart sensors which is in the machine tool. That's why they're talking about the concept of smart factoring respect to the sensors. Then other things like system analysis and integration, then other advanced manufacturing like 3D manufacturing, sorry, 3D printing, additive manufacturing now evolving. So that's what in the measurement science aspect. So you need a intelligent data analysis. That's what the big data, data science will come in the picture. Apart from this, other most important factor I want to convey here, how we are going to selection of your sensors for the application. So the key performance indicators when you're going to choose your sensors for the application. The other important one also I want to say how it's going to be connectivity. So connectivity now is not a problem on both. Mostly we should have more usage of the Bluetooth, wireless, and hardwired things are there. Hardwired, their communication buses are ready-made communication buses are there. Easily we can integrate with any kind of system. Only you have to initialize the file, then you can execute the data from there. It's possible now. But old days in traditional methods, you have to separate entity and you have to join together. You have to write your own program and you have to do. Now each and every entity now all maybe is closed with all combined with this all informations. Finally it give you the information about your the physical information about the particular world. Now come to the sensor machines. If you have any machine, if you have in your industry 4.0, if you could see the pressure sensors, proximity sensors, biosensors, position sensors, RFID tag. So if you go with any kind of a digital industry, you should have these kind of sensors. I will come one by one some of the sensors I will going to say. So I'll going to explain some of the sensors only. But we are talking about the smart machine, but we always call the sensor machine because the process only going to take place, but these sensors will give you the guideline. Then finally, whether you're going to make a process or not, that's what these are the sensor we can say is a sensor machines. So if you could see here, one of the best example is the laser welding system. I want to do a laser welding operation. If you could see here real time, so if you could see a real time, but the thing is when you go with detailing, with what are the sensors they have to using for the camera, so all kind of the trigger sense, how you are going to activate the table, how you are going to capture the information, then whether reach this particular information or not. So we are using n number of sensors when you are playing with, and also the connectivities with these sensors will give you the quality of the laser process to be happen in this particular process. So so sensors only giving the information about the about the environment at which how the equipments to be processed or tools to be processed. So based on this, we have to giving the information to the process, so it will going to do the operation. So similarly, for if you come with the smart inspection, because my area mostly with smart inspection, smart metrology. So if you have talked with any kind of a probing system or using any kind of laser system, so the probably we see there the sensors only the primary sensing to touch the component or not. With the non-contact aspect also, it's going to get the information from the product or component, whatever maybe we want to measure. So finally, so these sensors will give you a combination of informations. How you are going to process those informations further, you're getting your required informations. Like if you go with the SIM and other CMM machines, it give you a lot of information about analytically, but how analytically and also the physically. So how we have to process those data at the next stage. So what kind of sensor we have to use to identify? I want to maintain the gap between the your part and your product to be machined, tool and part to be. So how we are going to maintain? So what kind of sensor we have to place it? I want to touch the part at which whether it will have if you have any identification, any direction or identification. So based on this, we have to use the whether what kind of technology I have to use, whether it may be a contact type or non-contact type. Whether if you're not, I'm talking about the damage aspect. Suppose if you're using tactile sensors, so sometimes maybe wear and tear, and also it's going to damage your surface. Instead of that, how the laser can be used or camera can be used, how we have to process. So depends upon the application, we have to use the different kind of smart sensors for the industrial applications point of view. Then come with the multi-sensing fusion. Now is one of the technology, with this technology already happening in long years back. Sensor fusion, that's what I'm going to talk about also. Sensor fusion, the combination of one or more sensors, because some of the industries, I think they have been talking about sensor fusion, because 3 decades before they have started, but due to the sensing technology that not that much of not emerged during that particular time. But now they have been using a multiple sensors at which ensuring the quality of the product. If you like, using the space applications, using the underwater applications, so they're using the airplanes, they're using multi-sensing fusion technologies for to ensuring the quality of the data. Even now industry 4.0, now the one of the biggest issue, how we are to ensure the quality. That's what they're always talking about. They have to make some kind of standard, how we are ensuring the data which come from the one more sensor, then once again you have to check from the other sensor. So like that, that is evolving, that is going slowly. They're ensuring about they're talking about this kind of multi-fusion in the smart sensing technology. So so far I'm talking about the how the sensors in industry 4.0 they slowly come into the smart sensor. But generally the sensors what it does with you are going to measure or detect on the real world condition, but the smart sensors what it can do. So that's what it's a simplified electronic design. Whatever you have seen in the sensors, everything is there. But thing is, it is going to simplify the electronic design, so it come from ready to go for the any kind of application. It includes the all kind of information processing unit. Like so, it's going to detect, but finally we have a processor there. It will going to analyze your value, analyze your image, and it will going to transmitting the information or store memory. Some kind of memory unit always be there. It will store. So whenever you are the next processed need the information, it will going to transmit those next convert to the transmit the next stage, then further for the further processing. So mostly the smart sensors are the most important for any kind of original equipment manufacturers, because when they want for to ensuring the quality, they always expecting that what kind of smart sensor they have been using, how we are integrating with their equipment and machine tools which is available in the system. So that's what I told. So smart sensors are microprocessor driven. So it includes the communication capability and onboard diagnostic and give the information about the system. Then finally, if it is everything is there automatically, it give you the good efficiency, and we don't want to measure anything. So finally, it give you all stored data to be stored. You can process those data for further usage. If you see some of the characteristics when you're talking about the smart sensor, so how we are going to processing your signal conditioning your data with a harsh industrial environment, because how the rigidity robust design in your smart sensor, and local computing power, and what kind of boundary conditions, what range we have to work it. Then if you have a fault means how it is going to say. So what kind of alarms, info, how is self-diagnosis if I'm doing. Suppose if you have a temperature sensor, so in between they have talking about the small extra elements, sensing elements. If any one sensing element fails, so how we are going to react. So what way we have to get it the signals from the data. Very simple. If you go with if the motor is the basic element in any kind of a system, if you are connecting through your simple relays, if a motor is overheating, how we have to identify. So through your relays, you can identify one of your circuit won't work out. So you have to check with whether the current is coming in the circuit or not. So based on this, we can easily identify. So that's what is one of the major one when talking about the smart sensors point of view. That's what. So each sensor, so mostly they integrate with the sensing element analog in front end, and it is going to convert the sorry, analog to digital information. Then the data to be processed. For that you need a calibration to be fed. Sometimes based on the smart sensor unique ID. So they will calibration information they have been given for the every hundreds hours or 15 hour every every hour of operation or every particular data of operation. So they will feed this information, ensure that it will going to process it to be connecting with the current data and ensure that it will give you the correct data or not. Then finally, the output to be converted into a digital form for the further information. That's what generally it happened. It is always embedded with the processor. And nowadays, talking about Arduino, all Raspberry Pi, so many devices that have been talking. So there are the devices due to the devices because these devices are low power consumption, reliability aspect okay. But if you go with the long with mission tool protocols, it won't work out. But generally for the smaller application for a prototype model, so they have been using this all technology. But after that, we should go for the robust controller designs only is possible for to implementing the robo sense smart sensors uh, in the industry 4.0. So the if you are talking about the smart sensors, a combination of sensing element, analog interface circuit, analog to digital converter. So then finally the communication bus. So it have all in-housing with all. If you could see here, you can see. So only thing is this is a primary thing. Then finally going to connect it with whatever your system you want. So similarly for here, the primary thing, so that through this wiring, this one of the small devices there. So it will go through, you can connect to wherever you want, you can make it to connecting with your environment, with other systems, other integrated elements also. So additional functionality mostly depends upon the smart sensors. We have self-testing, self-identification, self-validation, then other capabilities like calibration, diagnosis. So sometimes maybe multi-sensing capabilities like some of the sensors, proximity sensors, able to measure the displacement, and also it will give you the acceleration, other things also. This also is possible when you're talking about the sensors point of view. Okay, so these are the about the smart sensors. If you could see here, when talking about the functionality point of view, one of the major one, because the basically the factory equipment is the first primary element. Then after that, when you're connecting to the smart sensors, I told already, the motor is a basic device. How we are going to identify the heating in this motor. So if a heating occurs means where you have to stop it. So how the smart sensors will give you the information to the through your communication through your control center. Sometimes the smart sensor waiting for the control center will give you the information to react, or sometimes the self diagnosis and automatically going to stop the process. So these things are majorly monitored by the smart sensors. That's what monitoring and analytics will play the major role, because communication and the controller aspect, a lot of ready-made devices are coming in the picture. But thing is, monitoring and analytics, the data are varying. Data are varying. It's not a common data when you're going with any kind of system. So data is always varying, depends upon the any kind of industry environment. Suppose today you're manufacturing one kind of component, tomorrow you're manufacturing different component. The sensor, same sensors we have been using. So how these sensors will play the major role with the different sensors data, how you are going to connecting with your the current system. So if you could see here, one of the video I want to show here, what is the difference between the temperature sensor with the smart temperature sensor. So that's what the manufacturing intelligence point of view. So how the smart sensors going to communicating the data, how it is self-assessing and self-diagnosing and calibrating to the physical world what is interacting with. So here, if you could see here, so the same sensor can measure the measure the displacement or the distance between the object and the other things, and also to measure the temperature. So like that, the multi-sensing capabilities with a single sensor to capable of transmitting the data so from to the your control center for the further process. So if you could see the one more video, so if you see ABB have a smart sensor mounted on the bearings, how the bearings can giving the smart informations when you are going to through your conveyor. I think hopefully you can visible. So if you could see here this particular video, you can understand that how the smart sensors can transmit the data, particularly with any hit of faulty or any heating things happen in the smart bearing. So the fault diagnostics can be identified by the sensor. So these informations further to be processed through your whatever the connectivity, through wireless or maybe through wired. So finally, some kind of small apps are come in the picture. So based on the data information, the apps to be process those information, give you the informations to you whether you have to change it or not. But the problem is when you are using the sensor, how the primary information to be collected by the sensor. So for that you need a lot of data to identify so where it going to make a failure, so what is the normal behavior of the system. So these things we have to identify. That's why the wearable devices are mostly they're doing this particular job. The similar thing they have been installed in most of the smart sensing applications in industry perspective. So there's a big scope in industries that have been talking about the installation of these get of smart sensors for existing industry. That's what the problem is. We have to how the traditional equipments can be converted to digital. So for that, how these smart sensors will give you the informations to you about the particular traditional equipment without changing the new equipment. So that's what the challenges are now they have been talking about here. So one more presentation you can go and see there about the smart sensors by the Banner Corporation by US. So if you could see there, the sensors are the eyes of the any industry 4.0. That's what they're saying. So generally, these sensors or smart sensors for applicable for multi-sensing capabilities. So depends upon the applications. So it may be varying, whether we're using optical or proximity or so what kind of sensor we have been using. So based on this, it will going to vary. So one more presentation, one more video. Uh, if you could see there, how many number of sensors are placed in these smart sensors in the robo environment. That's what this they have been talking about the enhancing, sensing, and diagnostics, self-controlling, self-monitoring. So these aspects they have been talking about the sensor. So why we want to use the sensor? That's what. So there is a time for installation, the equipment and environmental conditions, enhancing process operation, enhancing sensing, self-development, improve the safety of the worker. So many examples, so many advantages we can say when I'm going to use, going to use for your the smart sensor. But the costing is one of the biggest problem. They have been talking about the smart sensors point of view. Still, we have to work on this particular one. The common general functions in smart sensor. So these are the measurement, detection, guarding, and positioning. These are the common basic base sensing capabilities of any kind of a sensor. So if you want taking what kind of sensing technology we want to use it, whether it's simply a descriptive, it will only give you the information, or diagnostic for the usage for the next measurement, or maybe predictive and reactive, but then you have to take some kind of decision in the for the future to work on the particular system or integrate with the other system. So generally descriptive, diagnostic, predictive, now the prognostics will come in the picture. So the predictive and prognostics mostly nowadays the most of the sensors they have been talking about the sensing capability. They have been talking about this aspect. So I would go quickly with a aspect because these are the other things generally what you have studied in your engineering degree with the basic of sensors. Hopefully, I think most of them are from mechanical and other electrical background. So these are the very characteristics of sensors when talking about the smart sensor. Generally, what kind of operating principle, whether it may be electromagnetic or magnetic type. So what kind of embedded technology related with this all. Then the dimension, size, data format, intelligence, and whether it's maybe capable of generating the data, or maybe you need some kind of external power at which you have to use active or passive sensor. The physical contact point of view, whether it's contact and non-contact. So how suitable to the environment? This is one of the major one. Contamination will happen whether you are using the harsh and hazardous environment. So how will the sensor going to react on those environments? So this is also one of the important. When we're talking about the characteristics, other characteristics like what's the sensitivity, accuracy, precision. So these are the common one, how it is deviate from the true value. So what kind of error we can expect, how we are going to calibrate, how the self-calibration. So these are the things when you have talking about these sensors characteristics. So similarly, for if you go with the sensor fusion, I told already. So the sensor fusions now slowly is emerging once again, because one sensor is not enough for getting the data. So need multiple sensors, and they get the information, and they have to work out with the combination of these all values, combine these all values to process it and get the required value. So this also is going to happen in coming days. Multi-sensing fusion capability is one of the major route I'm talking about the sensor fusion. And robots also, they have been using this multi-fusion sensors. And one more problem with this sensor fusion, sensor integration. But however, now the things are totally happening with the lot of higher intelligent techniques, computing algorithms are coming in the picture. So they have using these kind of algorithm computing higher high-end computing algorithms to integrating the data and combining with get the record data. So apart from this, how you're going to selection of data, there are three major factors generally we called environmental factors, economic factors, and sensor characteristics. Mostly we look about mostly with the environmental factor, because how robustness and other things characteristics are nowadays, mostly most of the sensors ranges and capabilities are very high, but the economic factor is one of the major one, like the cost of installation, the costing, and availability in the scenario, in the industrial scenario, because some of the sensors availability is on, because if you have need a high resolution, a high precision, so become the biggest problem here, because I have suffered a lot when you're talking about the high resolution with the small sensing capability of zero point 0.1 mm diameter or zero point 0.2 that. So there's a big thing. We have tried with the L&D technologies with one project work. We have been working with 0.5 mm camera. We couldn't find out, because even L&D technology also not able to get from the camera from US and also from Israel. Israel have only 0.1 mm camera for and diagnostic purposes in healthcare system. We have get the one of the project from L&D Technology through TechGM. 2019 we got their first prize. 2018, sorry, 2018. So we got a diagnostic uh, system, one of the diagnostic system using a camera for cavity applications. But anyway, this thing is there. So the cost and availability is one of the biggest problem. And then apart from this, other things like I told already, accuracy, calibration, cost, and range. These are the common things. Apart from this, categories of we can use where we can use the smart sensors like mission control system, control component, safety aspect, robotics aspect, or motion aspect, metal handling, and assembly operations. Mostly they have been using these kind of applications. So if you list out the number of smart sensors, if you say whatever and category I'm saying about temperature, starts from temperature, pressure, all kind of sensors, mostly they have been using in all industry applications, is always embedded with the processor, microprocessor unit. So it is driven by once upon a time, we have to integrate with all machine, but not now. Like now, each sensor have own microprocessor. Only we have to collect those data through a common controller, and you can get you are processing those data at which you have to make a checkpoint. Only you can write a program on those sensor, then more than enough. Only you can command, you can to integrate means only through your call function. Then you can, from the call function, you're using remote function, it's like a function, it will come in the picture. Once upon a time you have to write all the programs continuously on the particular value, whatever getting from the different entities, like getting from the digital voltmeter, then finally you read those voltmeter value, then you can process it. But here not like that. So each function easily you can call and you can execute. So generally, these are the different type of sensors available in the market: photoelectric, magnetic type, capacitive type, then photoelectric reflective type. So these are the mostly used sensors in the industrial applications point of view. So capacitive, photoelectric through beam, retroelectric. These are the common sensors which I have been using in the smart sensor in the industry 4.0 applications. So this is one of the sensor what I have used in my research point of view when I go to characterize the profile, any surface damages, is one of the feature I have identified through my capacitive sensor with 0.5 mm. It's a capacity. So if you could see here, when you're going to see here, we cannot predict it, but when you're taking the measurement, you can see the changes in the voltage. It's not a small sensor, but we have only sensor, then different sensing electronics, and finally I have model it and have predicting those information. So if you have those data, so if you are given into the microprocessor, if you are nowadays all Arduino embedded boards are coming into picture, I can write those codes, then automatically I'm going to execute. It's becoming a smart sensor when you're going to use it in the any kind of industrial applications. So like that, we should have a number of applications for the capacitive sensor because it's highly sensitive when you are going to maintain the gap between the two sensors. Any small changes occurrence, any change in the any displacement, so it will going to identify. You're going to identify for the direction, presence of object. So many applications if you're going to see when you're talking about the capacitive sensors for the industry 4.0. So it will going to use it for the displacement, mostly for displacement and presence of this object. So like that, we should go with the photoelectric sensors. Then if you go with the photo, I'll a little bit quickly I have to go. I'll give you these slides. I think these slides are commonly, you already have studied for this. That's what I'm only talking about the details of why we got to go for the smart sensor. Other things you can easily interact. So I quickly go and with this all photoelectric sensors, then image sensors nowadays they're talking about because image vision we have been working with the bimetal bearing for to dimension measurement. So one of the difficult process what we have get it from the bimetal bearing. One of the project work for 17 lakhs we got it for to measure the different dimensions of the part. Automatically going to identify the detecting the part and orienting the part, and finally we have to measure all the features in the bearing ring dimension and if you have any damages through your image vision system. We have placed 4 to 5 image machine vision systems, cameras at which different orientation at which we have identified the fault. So these are the various sensors which is available in the market. So these are the smart sensors. Immediately you can capture the information, then it will store those information, you can transfer. These are the old type of camera sensing unit also there. These are the currently used camera. You can easily become visible there itself, get it your information. Then you can that particular time itself the actuator. Once the sensor give the data, the actuator will give you whether the bottle is filled or not. Based on this, it will going to actuator going to react and displays the bottle. So like that, we should have most of the sensors, mostly image based, optical based, and capacity based and inductive based. If I could go with then other electronic sensors for used for industry applications for mostly for the high end application distance higher distance applications because capacity inductive or ranges are biggest for all. So ultrasonic sensors are used for mostly for the higher end high distance applications also they have been using with direction presence of the object mostly for underwater applications, but apart from this they have been using in the different applications. So other important thing is because ultrasonic capacitive photovoltaic are common non-contact sensors. That's what they have been talking here. It won't influence the colors and or other aspect like shape, other things. But if you go with proximity, other things, so your line of your through beam, so any complex shapes also we can easily to measure through this kind of ultrasonic sensors. It depends upon the application. We have to use it. For even uneven shapes also you can use it by ultrasonic sensor. Other safety sensors like light curtains, like proximity sensors, relays, limit switches is a commonly used devices which is mostly used in the industrial applications point of view. And the rotary sensors, the internal sensors mostly used for to know the position of the tool. So based on this, they have been using these kind of. So these all sensors nowadays mostly embedded with the system. Slowly they're making the embedded with the system. They're connecting with the electronics and microprocessor. Then finally they are used as a smart sensor in the current industrial applications. So you know that the smart sensors current challenges because the flow, product flow, because time is one of the major feature. The motion handling of the sensors become a major play when I have been talking about the in the industry 4.0. So production flow. So we have to always talk about the smart sensors and the time for to taking those informations. So this is very important one. The motion, if you have any motions, is one of the biggest problem here. Okay. So next thing is my audio is okay. I think somebody have said that my audio is not there. Okay, anyway.
Okay, sir. Okay, sir.
Okay. Then the other important thing is challenges in smart sensor environmental aspect, because harsh environment, hazardous environment, contamination environment is one of the biggest problem. Even though if you can use any high robust design smart sensors, also some kind of malfunctioning, we have to go and replace. We can't change it. So these problems occurs, and costing also. If you have any issues direction, if a self issues directions, okay, self diagnosis okay, but sometimes it won't, because if you have full self diagnosis, the cost of sensor will come and become the bigger. So other multi features we are expecting multi sensing capabilities. The other most important thing is when you're using a smart sensor, because when you go with the smart, always data will come in the picture. How we are going to handling the data, because what kind of data? That's why I told earlier, the quality of data has become one of the major one. Okay, so this is what the challenge is. What I have to from the smart sensors point of view. So you know that today's hyper competitive world, the speed, accuracy, and reliability is very important. So in the smart factory also, we have to go with speed, accuracy, reliability. So you have to use the appropriate smart sensors, because sensors are the heart of the smart manufacturing, because these are the eyes of the smart manufacturing. Heart also we can say is eyes, because without this, if any one malfunctioning, the smart will go on. So this is very important. That's what the new generation mostly depends upon the how the intelligences are connected. Finally, one more thing we want to check, because cost of the sensor, the sensitivity of the sensor, integration with other system. Still, they have been talking. Nowadays, currently there are a lot of sensor come in the picture, but anyway, but the good sensors, especially smart sensor, are a little bit costly, even though we have been talking. But if you go with installation only, implementation, you can understand that how is difficult, because what we have tried with some of the consultancy work, we using some of the bimetal bearing, I told L&T, getting the sensor itself and then the other electronics to installing and studying those the electronics becomes difficult when you are going to buying and taking and fitting, and it is not, sometimes it won't work out. So that's one of the biggest problem. Apart from this, choosing the sensor, because other important thing is appropriate to the your current requirement. So that's another important one. Then apart from this, these things word big data, because you are generating the data through your sensors. So processing the data and predicting and prognosing is one of the biggest challenge. Okay, so thank you. Thanks for your opportunity. I think thanks to Shanmugesh inviting me for this one, and I think somewhat I have to fulfill. I'm little go fast, but anyway, time constraint. I don't want to distribute. Thanks for your support. If I have any questions, please. I have one or two questions with me for. So only Shanmugesh, if you could allow me, I will post this Google form. Shanmugesh.
No problem, sir. No problem, sir.
I think participants, please use this Google form. Could you please answer the questions what I have covered? So, and also now, if you have any questions, please interact me. You can submit this Google form. So once, if you have any questions, please interact. Otherwise, you can start to the work with the Google form. So thank you. Thanks for your support. If any questions, maybe I can wait for it.
Any questions from the audience?
Sorry. I think thank you.
Can you post this in the chat box, sir?
Yeah. So I posted in the chat box. Already I have posted.
Yeah, it is okay. It is okay.
I will share you some all questionnaires to you.
Okay.
Maybe I can share the slides also. Please share to them. Maybe somewhat they may be useful for you when they have presented to the their students.
Any other doubts?
I think so. It's not any doubts, please, participants. I know that is one of the emerging area in Industry 4.0. Smart sensors. There is a big opportunity in the instrument capability and the controlling aspect when using a sensor. So, if you have any questions, please. Or otherwise, Samuel, I think you can.
Okay, sir. If I know other discussion or clarification, let me wind up. Any other?
I think I've always, if you're asking the question, they won't ask generally.
Okay, so then we can wind up.
Yeah, thank you.
So
Thank you,
once
Shamil.
again, thank you, Dr. Muraj, sir. So thank you for your participation and thank you for accepting our invitation. And again, thank you very much for making your presentation today because we had no other option to go for another speaker. So thank you very much again for helping me in organizing this STDP. So let me invite Nibin sir for giving the vote of thanks.
Okay, thank you, Dr. M. Murugarajan sir, for your very informative session on smart sensors in digital manufacturing. I hope everyone will be very benefited from this section. And so, on behalf of entire Mechanical Engineering Department of Vishwanath College of Engineering and Technology, I express my sincere gratitude to you, sir. I also thank all the participants. Thank you.
Thank you, Vipin, and thank you, Shanmugesh. I think I'll share this the Google form and presentation to you also. Meantime, I will. They will once they will upload submit the Google form, they will get their answers also. So no problem.
Okay.
Easily you can understand. Thank you, Shanmugesh.
Yes, sir. Thank you very much once again, sir.
Thank you.